Okay. Today in Algebra 1, we're covering Lesson 2.5, which is literal equations. Literal equations are equations with two or more variables. All right? Solving these will follow the same rules as ones that just have like the one-step and two-step equations. Same rules. The only difference is we can't do the same type of math with them, which means that we can't, simplify them to make smaller numbers. Okay, and that's what's going to throw most people off. Okay, so let me ask Alex, what makes an equation a literal equation? What makes an equation a literal equation? So two or more, right? So it can have two, can have three, can have 100, can have 1,000. As long as it has two or more variables, it's a literal equation. Okay. Some examples of that would be maybe like this one. Does this have two or more variables? It does. What is this equation? Yes, area of a triangle, right? Area is equal to 1/2 base times height. It has 3, right? Okay, how about volume equals length times width times height. Which type of volume are we dealing with in this one? Squares and rectangles do not have volume, they have area. Rectangular prisms, right? Or a cube if it's a square prism, right? Okay, good. And there's many, many more like those. Okay. Here we have a literal equation. It's about pizzas and sandwiches. All right. So we have the equation 10x plus 5y. All right. Let me ask Amy, why is that a literal equation? Two variables, which are x and y. What does x stand for? Pizzas. What does y stand for? Sandwiches. Okay, good. Now, it's all right, there's more than one Amy here today. All right, so in this equation, the first thing that we're going to do is we're going to solve this for y. We're going to solve this for sandwiches. Okay? So what we want to do is we want to get y by itself. And we're going to do the same types of steps as we did when we had one variable. Okay. So when I look at that y, what do I want to get rid of first? The 10x. Okay. When we are looking at y as the variable we want to solve, we're going to pretend like x is just a regular number. Okay. So we're going to pretend like we maybe have something like this. Okay? So over on this one, we would do what first? Yeah, minus 10, minus 10. On our literal equation, we're going to do the same thing first, except for it's going to be minus 10x minus 10x. All right? On the left-hand side, we have 5y. On the right-hand side, this kind of drove me nuts during our test last chapter. All right? What's 80 minus 10x? Here we go, 80 minus 10x. Okay, I'm glad I heard it. It is not 80x, it's not 70x, it's not 70. Are 80 and 10x like terms? Can I put those together? No, so I have to leave them separate, okay? Which one should I put first? 80 minus 10x is right. Okay, nothing wrong with that. But we should get in the habit of putting the variables first. Okay? It's just a standard formal way of doing things. You put the variables first, and then you leave the constants afterwards. Okay? I'm not going to mark you down if you mix them up and have them flip-flopped or anything like that. But as you go through math into geometry and then algebra 2, you should be getting in the habit of putting the variables first. All right. Then what am I going to do? Divide by 5. divide by 5, right? I have to divide by 5 everywhere. Y equals, that's a negative 2x plus, what's 80 divided by 5?
A number.
It is a number.
16.
16. Somebody else might have said it over here too, but 16.
Is this the x plus b?
No, but we're going to get there soon, I think.
Why did you change 10x into like an addition to plus 80?
Because remember that plus sign here, so the question is like, why is that a plus sign instead of a minus sign, right? Well, if we look here, the minus sign belongs with which number? The 10. So the minus sign stays with the 10 here. Is this a positive or a negative 80? Positive, so the positive sign stays with the 80. Okay? So when you divide, you have to divide each piece. Okay? Every plus or addition part you have to divide by. So you have to divide here and here. Yes?
So you can't go 80 minus 10x, but you can go negative 10x divided by 5.
Yes.
That makes sense.
It doesn't make any sense? Okay. So let's look at the reason why we can. So the question is like, if I have, I'm going to use smaller numbers, okay? So if I have like, we'll use 2x plus 5. Okay, the question is, why can't I do this one, but I can do, I will do 4x divided by 2. Okay? So the question is, why can we not do this one, but we can do that one? Okay? Well, let's look at what this one means. Okay? It says I have 2 x's, and I'm going to add into it 5, right? So I'm going to put all these together, right? How many do I have? I have 2 x's, and I have 5. Okay? That's what that one means. Over here, I have 4 x's. If I divide it in 2, means I'm going to cut it in half, right? If I cut it in half, how many x's do I have? Okay? So that's why you can't do addition and subtraction, but you can do multiplication and division. Okay? That's a good question. Okay, here we have what type of equation, William? Literal. Why is it literal? Yeah, it's got 2 or more, which is more than 1, right? How many variables does it have? 4, right? Has A, B, C, and then x. This one, we want to get x by itself, okay? And this one has a little bit of a trick that we need to remember, okay? This is going to be one that you have to keep in your memory so you can do them every once in a while. When you want to solve for a variable, like that x, and those x's are split up on the same side of the equal sign, we need to do distributive property, but backwards, okay? So the distributive property looks like, so it'll be equal C, and there's something and something there and something here, right? And there'll probably be a minus sign there since there's a minus sign here, right? So we need to decide where those numbers, what are not numbers, but what letters are going to go where? All right?
Doesn't the x go outside?
X does go outside. What's going to go inside then? A minus B. All right? So both of those ones share an x, right? So what we're going to do is we're going to have them share that x, but we're going to have them share outside of the distributive property, leaving us with A minus B inside. Good. Good job, Carlos. Now, we need to get x by itself, right? What's happening to x right now? It's being times by the whole parentheses, right? So how am I going to get x by itself? Divide by the whole parentheses, right? If it's times the whole parentheses, you have to divide by the whole parentheses. You can't divide by a and then cancel all a's. You have to divide by everything. So now I get x is equal to those cross off, leaving with c over a minus b. You want me to circle it? Is that okay? And you circle your answer. My bad. I almost didn't get the right answer because I almost didn't circle it. But it's circled now. Okay, any questions over this one? Okay. Formulas. Okay, I'll give you a couple examples of formulas at the very beginning. Formulas are very good examples of literal equations, right? Example of that is the area of a rectangle. Area equals length times width. There's more formulas found on page 110. You might want to put them in your notebook. Okay? You might want to. There might be a problem sometime on some test or quiz that you need one, right? So there's more formulas on page 110 that you can copy down once we're done. So here, I have a equation. We're talking about circumference, right? Does anybody know the formula for circumference of a circle? So you guys don't remember, but where do you think you could find it probably? Page 110, right? It's probably right there. So, I'll let you use your notes, right? Yeah. If you have a formula sheet on your notes, then yeah. So, anybody remember? Nobody remembers what circumference is. Well, what does circumference mean? Yeah, it's like perimeter, but it's all the way around, right? All right. Pi r squared is area. Do you have it, Amy? It's close, okay? Area and circumference of a circle are very similar, right? In fact, the only difference is that 2 right here, right? We changed the c to the a, and then the 2 becomes an exponent. It's the only difference, right? So they are confusing. Right? That's why we need to have them down in our notes. So here we have circumference is equal to 2 pi r, okay? What do I want? What are they asking for? The radius, right? What is the radius? So which variable do I want by itself? R, radius, okay? So how am I going to get r by itself? So I need to get rid of the 2 by dividing 2 and pi, good. And I need to divide by 2 pi over here. R is equal to c over 2 pi. And not done yet, right? Because they want to know when the radius, what the radius is when circumference is 64. What am I going to do with that 64? Yeah, I'm going to evaluate, right? So I'm going to put in 64 for my c over 2 pi, and that's going to equal some r, right? How many problems do I need to do right now? 3, right? 25 and 102 as well. So I need to do 25 over 2 pi and 102 over 2 pi, okay? I need some help figuring these out, okay? When you have one, raise your hand. Which one did you do? 64 and you got what? 100.8? I think that is wrong. Johnny? 100.5, I think that is wrong. Now we should think it to ourselves, is it reasonable, right? If we're dividing, should the number be bigger or smaller than 64? Smaller, okay. Which one are you on, Hunter? Okay. 10.15. That looks better to me. Okay. Still have 2 more. Put your hand out. Alcadio.
402. I got 16.233.
2, 3. So you got 16.23 for 102 and 25? 3.98. All right. Good. Any questions over this one? Yeah, John. How did we get these ones? All right. Let me see how you're doing on your calculator, because I think you might be doing something wrong where you end up timesing when you should be dividing. Okay. So on your calculators, you need to be careful, because if you type in on one of the ones excluding the yellow ones, or even the yellow ones, but if you type in, what do we do? 64 divided by 2 pi, right? This is what your calculator does. It does 64 divided by 2, which is 32. 32 times pi is like 105 or whatever it was, okay? So you need to be careful. If you have parentheses buttons, does yours have a parentheses button? You need to make sure you put parentheses here, right? Because remember, there's invisible parentheses on big fraction bars, right? So you need to make sure you put parentheses there, and then you'll be right. Good. Okay? Good one. Here in biology, the monarch butterfly. It's the only butterfly. You guys know what the monarch butterfly looks like? Yeah, it's the classic butterfly. Only butterfly that migrates annually north and south, right? The distance that a particular group of monarch butterflies travels south is 1,700 miles. That's a long ways, right? I mean, 1,700 miles is a long ways for us. And butterflies are like 100th the size of us, 1,000th the size of us. That's like us going around the world. You know, it's a big deal. It takes a typical butterfly about 120 days to travel one way. What is the average rate at which a butterfly travels in miles per day? Does anybody know the distance formula? Where would you guys be able to find it at? 110. All right, what do you have for it? Distance equals rate times time. That's good. If you take your rate, which is your per, right? If you're driving in a car, what's the per? What's your rate going to be? Miles per hour. That's your rate. If I am going to go for a jog, what's my rate going to be measured in? You could do feet per second or something like that, or miles per hour. Your car, right? Miles per. That rate is always a per. So here, do we know what the rate is? No, that's what they're asking for. What is the average rate? So what should I solve for? R. How am I going to get R by itself? So I get rate is equal to distance over time. Good. Do you have the answer? Why don't you tell me how to set it up? So that's miles, right? Okay. 120 days. And that's my rate. Okay? Okay, we'll ask over here to Hunter. What do you get? Do you have the answer too? I'm going to ask you because I'm tired of hearing Hunter talk. You're talking right now. I'm taking back that ask. Now it's fun because we get to watch Hunter pout. All right, Takeda, what'd you get?
14.16
Miles per day, and that's equal to our rate. Okay? So butterflies fly for 100 or 14.616 miles per day. So that's like from like Echo to like the river, right? It's like from Hermiston to Stanfield and back. So Stanfield to the river then. How about that? Okay? So that's how far they go in a day. Right? That's pretty far for a butterfly, right? I mean, now let's look at this. 120 days. How many days are in a year? 365. Right? So 120 days is about 1/3 of a year. So that means they spend 1/3 of the year flying south, 1/3 of the year flying north, and then they only have 1/3 of the year to hang out. Butterflies, they work too hard. All right, this is our homework assignment on page 113.